welcome back to my channel and all the best for the upcoming class 12th CBSE chemistry board exam. So we have this exam scheduled on 27th Feb. For this, I am giving you today a checklist of all the possible questions, name reactions, conversions, distinction pairs, and conceptuals worth 3 marks that can be asked in the coming exam from organic part. So organic weightage is approximately 33 marks. So I'll be discussing about organic. I'm not discussing the details, but I'm telling you what should be your checkpoints after you revise this. So I hope this helps you in your preparation. Let us go ahead with it. This is a complete list of chapters that you're supposed to be doing. And in front, I have shown you the weightage. So if you just look at the organic weightage, it comes out to be nearly 33 marks out of a total of 70 marks, which is a big deal. So I would say that you give your first attention to organic chemistry, prepare it well. What are the components that you should be done after you prepare from organic? The name reactions and the various name reactions from each chapter. From haloalkanes and haloarenes, you should be knowing Finkelstein's reaction, Swartz, Sandmeyer's, Wurtz, and Wurtz fitting, right? And also the limitations of Wurtz reaction, what kind of compounds it can be used and where it cannot be used. So go through that in detail. Then for alcohols, mainly esterification, fermentation, Kolb's reaction and RT reaction, ethers, Williamson ether synthesis, Friedel-Crafts, and nitration. Now, Friedel-Crafts reaction, basically Friedel-Crafts alkylation and Friedel-Craft acylation. Both of these are important in every chapter. So the last topic of every chapter is aromatic compounds. So for all the compounds, like starting from aromatic halides, aromatic alcohols, aromatic aldehydes, aromatic amines, etc. For all these compounds, the last topic under EAS is always Friedel-Crafts reaction, under which we have Friedel-Crafts alkylation and acylation. Alkylation brings in an alkyl group, and acylation brings in an acetyl group or acyl group. So you should know, effect of each of these groups on benzene ring. Like for example, if we are doing any of these reactions on Cl or OH presence, we are going to get the major products at para position. And for CHO or COH kind of groups, we are going to get these at meta position. So these are the points that you have to do for every chapter. So Friedel-Crafts reactions means Friedel-Crafts alkylation, Friedel-Crafts acylation. And under this, also be clear about what is the difference between acylation. Acylation is done with RCOCl, introducing the group RCO. And alkylation is done with alkyl halides, introducing the group R. And supposing I ask you what is the difference between acylation and acetylation, then must be clear about this point. Acylation is a general term where we are using RCOCl group, and acetylation is specific where you're using the acetyl group. That means R gets replaced with CH3. And the next reaction is nitration. Then for aldehydes and ketones, this is a sequence of reactions that you should know. Under ozonolysis, you can get an indirect question where they either give you the products. Let us say I tell you the products of ozonolysis are these two compounds, and what is the starting compound. So simply remove this double bond O, put a double bond here. This is the starting compound. So what have we done? We have simply taken this off and put a double bond instead of these. Clear? So they can also ask you what is the significance of ozonolysis. It helps you to determine the position of double bond in an alkene. Then Rosenmann's reduction, Stephen reaction, Itard reaction, Gatterman-Koch reaction, Cannizzaro, aldol, crossed aldol, haloform. And out of these, I would say these three have a special importance. These are extremely important. They can be asked in different ways, either write a note, give an example, or give the products of aldol condensation or crossed aldol condensation with a given choice of compounds. Let us say they give you CH3CHO and ask you to give a crossed aldol product with CH3CH2CHO. So I just help you to recall the major mistake children do is removing this H, but you have to be careful. Only alpha H is what you have to remove. So CH3, CHOH. This much part is going to convert to this, and then CCH3, C double bond, O and H. This is what the product is going to be. So what you have to remember here is that this H has been used to convert to a carbene ion. Clear? This is the only mistake children make while working on this. So just remember to use the alpha hydrogen. Then haloform reaction. Haloform reaction in general, but when it comes to distinctions, we are going to talk of iodoform reaction. Carboxylic acid mainly causes electrolysis, HVZ reaction, and again Friedel-Crafts reaction. Compounds containing nitrogen, we have this series of reactions. I'm not going to read out all these. So these reactions are important that you should know. And out of these three are less important by name. They have a less chance of being asked as by name, but otherwise the reactions are important. Okay. Now Hoffman's elimination is not part of boards, so you can even avoid this. Then we have the next as conversions. Now, what are the important conversions under haloalkanes and haloarenes? We have ethane to bromoethane. Practice these. These will include almost all the conversions that can be asked. Bromoethane to ethanol, ethanol to ethene, ethene to ethyl bromide, chlorobenzene to phenol, and chlorobenzene to aniline. In case you want a solution to any of these, just put it in the comment and I'll provide. Alcohols, phenols, and ethers, ethyl bromide to ethanol, ethanol to acetaldehyde, acetaldehyde to acetic acid, phenol to benzene, phenol to salicylic acid, phenol to anisole. Practice these conversions. Okay. So similarly for aldehydes, ketones, and carboxylic acids, here we have a list of a few conversions. You can just pause it and go through. And in case there's any doubt, you can put it in the comments below or mail me. I can send you a solution PDF. Then we have organic compounds containing nitrogen. Just see that you know these conversions: nitrobenzene to aniline, aniline to benzene diazonium chloride, and then benzene diazonium chloride to phenol to benzene to iodobenzene, chlorobenzene, bromobenzene, and so on. Okay, you just have to remember the reagents that convert benzene diazonium chloride to different compounds, which is given at the end of the chapter, nitrogen containing compounds. Now, distinction pairs, very important, can be asked in the form of a multiple choice question or they can be asked as a straight direct question. So I'm going to deal from all the chapters, I'm going to deal with you first general concept. Like from alkyl halides, the general concept for most of the conversions is an alkyl halide is treated with aqueous KOH forming ROH and KX. The purpose is to convert this covalently bonded halide to ionic form. KX is an ionic compound, RX is a covalent compound. Ionic purpose of taking it to ionic form is now it's going to be present as free X negative in aqueous solution. So when you treat this aqueous solution with silver nitrate in presence of dilute nitric acid, you're going to get AgX, and this is formed in the form of a precipitate. From the color of the precipitate, if it's a white PPD, it means AgCl. Yellow, pale yellow means AgBr, and proper yellow means AgI, right? I've given different colors, children. So sometimes visually seeing something helps you to recall and remember. Okay, so and just remember one thing about distinctions. Sometimes, and most of the times, the distinction questions, please be very clear about this. Every time we go for checking, these are the points that are kept in mind while attempting a question about distinction pairs. See that you mention the reaction, the balanced chemical equation. You mention what is the observational outcome. Like in this case, the observational outcome is a white PPT or a yellow PPT or a pale yellow PPT. Okay, and then you mention which out of the two pairs will give this test and which will not. That will give you a complete score. Okay, so don't just write treat it with dilute nitric acid or treat it with silver nitrate and precipitation shows presence. No, please prepare it well. I have tried to give all the distinction pairs and details. These can be asked in different ways, not essentially they directly ask you the distinction pair. These questions can be asked in different ways. So each of these concepts is important for you to know. Then Second point about the distinctions of alkyl halides is any compound which has Cl on a double bonded carbon or sp2 carbon, such as CH2CHCl. This is sp2 carbon. This is vinyl chloride. Okay. And this is phenyl chloride. Please be extra careful. This is phenyl chloride. Here also Cl is attached to sp2 carbon. So both these compounds are not going to show the test we have just talked of. Why? Because there is going to be a partial double bond character in both these due to resonance. If this is asked as a subjective question, then you must write the resonating structure of which out of the two is asked. If they ask you to explain, you should know how to make the resonating structure and explain and make more resonating structure than explain that this part has a double bond character, hence it doesn't undergo hydrolysis easily. So vinyl and phenyl chloride does not undergo hydrolysis easily, and the reason is they show resonance. Okay. So this question can be asked in any of the various parts. I hope this is clear and understood. So, and another thing, children, I want to bring to your notice, children, really make a mistake in this till the end. This compound is benzyl chloride. Benzyl chloride. Till long, children keep on making a mistake when it comes to this. This is phenyl chloride. So if we are doing the test we just discussed, that is treating first with aqueous KOH followed by treating with dilute nitric and silver nitrate, if we are doing this test, then we will get a precipitate in this case, but in this case, there will be no precipitate, right? Because this cannot undergo hydrolysis, but this doesn't have the double bond character. There's no resonance in this case, so this will show. Be clear about this important concepts. So for haloalkanes and haloarenes, each of these, now these are the most often asked distinction pairs. And how do we apply the points that we've just done? I've just explained to you chlorobenzene and benzyl chloride. This is not going to give the test with aqueous alkali and silver nitrate, but this one will. Now the cyclohexyl bromide and benzyl bromide, it's the same thing. Ethyl chloride versus vinyl chloride, again same. This will give, whereas vinyl will not. Alyl chloride and vinyl chloride. What is alyl chloride? Alyl chloride is where there is no resonance working. So this is going to give the test, but vinyl chloride is not going to give the test. Ethyl chloride versus ethyl bromide versus ethyl iodide, the same test, but what will be the difference here? In these three cases, there will be a difference in the color of the precipitate. AgCl is white, AgBr is pale yellow, as we discussed, and AgI is proper yellow, right? So that's the difference. And now the last one is chloroethane versus chloroform. So when it comes to chloroethane and chloroform, we're going to use carbylamine test for chloroform. So chloroform, aniline, KOH, we get phenyl carbylamine, KCl and water. And must mention unpleasant smell is the observation here, right? The observation is going to be unpleasant smell. Chloroethane is going to show no change. And learn balanced chemical equation. In any case, this can be asked as a named reaction also. This can be asked as a distinction test. This can be asked under amines, anywhere. So this is a very important reaction that you must keep in mind. Then next is Lucas test. So this is first used distinguishing any primary, secondary, tertiary alcohol, ROH plus HX. Remember, concentrated HCl. This can be asked in multiple choice questions also. We use concentrated HCl and hydrogen chloride. This combination is called Lucas reagent, and the product is alkyl halide and water. Since alkyl halides are insoluble in water, if they ask you this point somewhere conceptually, remember, alkyl halides are insoluble or sparingly soluble in water. Hence, they show turbidity. Whereas the original alcohol solution is a water soluble solution. So this was a clear solution. So when you treat alcohol with halogen acid in presence of anhydrous zinc chloride, we get turbidity, which is immediate for a tertiary alcohol, after 5 minutes for secondary, only on heating for primary. And this helps us to distinguish between primary, secondary, tertiary alcohols. Please remember, Do not use Lucas test as an identification test for alcohol. Use it for a distinction between primary, secondary, tertiary alcohols. Very important, iodoform test can be given by all compounds which have this group CH3, CHOH, that means two ones, or CH3CO group, which means two ones. Ketones, which have CH3 with CO, that is methyl ketones. For boards, you need not bother about these examples. So when it comes to ketone, which is a methyl ketone, or instead of this, if we had, let us say, we had a 2-ol, this with this oxidizing ion is going to convert to this, so final reaction will be the same, and with sodium hydroxide iodine or with sodium hypoiodide. This is sodium hypoiodide. Any of these can be used and we get these products. Please remember to learn the balanced equations, and iodoform is the yellow precipitate. If in general haloform reaction is asked, then also it's going to go like this. Instead of iodine, you're going to put X2. Instead of I here, you're going to put X. Here you will give CHX3. But then only iodoform has an observation. It's a yellow colored solid insoluble, that is in the form of a PPT. So only iodoform is used for distinction. In general, haloform reaction cannot be used for distinction. Okay. Now, coming to phenols, neutral ferric chloride. With neutral ferric chloride, phenols give violet color. With bromine water, white PPT. And with diazonium salts, they give an orange dye. This is the azo dye test. Azo dye test. This is bromine water test. And this is neutral ferric chloride test, right? So any of these three tests can be done for identification of phenol, or similarly to distinguish between phenols and any other compound. Then for carboxylic acid with neutral ferric chloride, they give a buff PPT. We do not use this for identification of carboxylic acids. We generally do not prefer, because buff is not a very clear indication. But this is observation is of importance if you are asked to distinguish between a carboxylic acid and a phenol. So phenols with neutral ferric chloride give a violet color, whereas benzoic acid gives a new buff precipitate with neutral ferric chloride. Okay, with sodium bicarbonate, we get a brisk effervescence due to evolution of carbon dioxide, according to this reaction. So carbon dioxide evolution is observed in the form of a brisk effervescence. Using these particular reactions that we've just discussed, these are the pairs that you can be asked. Like primary alcohol, let us say you're asked to distinguish between ethanol, then isopropyl alcohol, or tertiary butyl alcohol. If you're asked to distinguish between these three, you can use Lucas test, as we have done, primary, secondary, tertiary. Ethanol versus methanol, you can do iodoform for this, and methanol will not show. Ethanol and propane 2-ol, both will respond to iodoform. So we are not going to use iodoform here. So what are we going to use? We are going to use Lucas. Lucas test, this will not give any turbidity. This is going to give turbidity after 5 minutes. It's going to give turbidity only on heating. Why? Because this is a secondary alcohol. This is a 1-degree alcohol. Phenol versus alcohol, you can use any neutral ferric chloride test or bromine water test or azo dye test. Alcohols will give none out of these. Similarly, phenol versus carboxylic acid, you can use either sodium bicarbonate test, carboxylic acid will give, phenol will not, or you can use azo dye test, or you can use bromine water test, which will be given by phenol. Then ethanol versus ether, you can use iodoform test for this distinction, right? Now, moving on to general tests for aldehydes and ketones. For aldehydes, we are using Tollens test. Tollens reagent is ammonical silver nitrate. It's basically silver nitrate, ammonium hydroxide. Silver nitrate and ammonium hydroxide together create this active species in the reaction mixture, and any aldehyde with this is going to react to produce these products, where silver mirror is the observational outcome. Okay. Similarly, with Fehling solution, it is ammonical copper sulfate, originally blue in color, and finally the indication is brick red color. Initially blue and then brick red. This is initially blue. Fine. So aromatic aldehydes do not give Felling's test, but aromatic aldehydes can give Tollens test. So if you're asked to differentiate between benzaldehyde and ethanol, you can use Felling's test. Clear? DNP test, another test, important test. DNP is shown by both aldehydes and ketones. So in case you want to distinguish between an alcohol and a ketone, both of which give iodoform test, then we can use DNP test. For this, what is DNP test? Any carbonyl compound. Carbonyl means any aldehyde or ketone. I have written here carbonyl. So this is in general any carbonyl compound. Any carbonyl compound with 2,4-DNP, 2,4-dinitrophenylhydrazine is going to give a colored product, that is 2,4-dinitrophenylhydrazone derivative. Which is a colored product? The color depends upon the compound that is used. And this is not shown by alcohols and carboxylic acid, so we can use it for distinction with those. Now, aldehydes versus ketones, what can we use here? We can use Tollens or Fellings. This is not going to give. Ethanol and propanol. Now, propanone and ethanol, this and this. If we look at this, both of these are going to give iodoform. So we cannot use iodoform to distinguish between the two. What are we going to do? We're going to treat this with DNP, and this is not going to give any response with DNP. So ethanol and propanol. Again, we can use Felling, Tollens, any of these. Formaldehyde, acetaldehyde. We can use iodoform with this. Formaldehyde will not give iodoform test. This is going to give iodoform test, right? Then acetone versus acetic acid. Acetone versus acetic acid. Again, this is a ketone. We can use DNP with this, but acetic acid is not going to give DNP. Or we can use sodium bicarbonate. This is going to give brisk effervescence. This will not give. General carboxylic acid distinctions. Methanoic acid and ethanoic acid. I've written it twice actually. Formic acid or acetic acid is the same thing as methanoic versus ethanoic. Clear? Formic acid gives Tollens and Felling's test like aldehydes because formic acid is considered to be a bifunctional organic compound having both the aldehyde, some reactions of aldehydes also shown along with carboxylic acid. So formic acid only, not all acids, only formic acid gives Tollens test and Felling's test, and it also, formic acid also reduces mercuric chloride to mercurous chloride, which shows a white PPT. But all this, both these, all the three of these tests are not shown by acetic acid or any other acid, right? And then methyl acetate versus ethyl acetate. What are you going to do? The direct test is not available. We are simply going to hydrolyze. Acid catalyzed hydrolysis is going to produce acetic acid and methanol. Here, acetic acid and ethanol. And then we can proceed with the same solution. We can proceed with iodoform. Ethanol will respond to iodoform and methanol will not respond to iodoform. These are the distinction tests. And then we have the last chapter, nitrogen containing compounds. Hinsberg test, primary, secondary, tertiary amines. Must know the name. You can be asked a question through name, structure, benzene, sulfonyl chloride. Okay, and this is a 1-degree amine. And you must also be clear about the structure of benzene sulfonyl chloride. It is benzene ring with S and double O, and Cl. This is benzene sulfonyl chloride plus ethylamine. What really happens is this Cl and this H goes and we get a product. This is N-ethyl benzene sulfonamide, right? And this is soluble in alkali. Why? Because when you add alkali KOH to this OH is going to take up this acidic H and form a potassium salt of this compound. Potassium salt N minus K positive with C2H5, right? We get a potassium salt, and ionic compounds, are soluble in water as well as in aqueous solution. So this we say is soluble in alkali because it reacts with the alkali. Whereas in case we have a secondary amine, it will react with benzene sulfonyl chloride to form N-diethyl benzene sulfonamide that will be insoluble in alkali. And the third one, tertiary amine, is not going to be soluble in either. Okay, so we can also use this test for separation. Remember, Hinsberg test is used for identification as well as separation of primary, secondary, tertiary amines. Then next important point, primary aliphatic as well as primary aromatic amines, both will give carbylamine test. Carbylamine test I've already explained. So both remember aliphatic amines like RNH2 as well as when NH2 is on the benzene ring, something like aniline. Both these are going to give carbylamine test. Okay. And then azodite test is given only for primary aromatic amines. So this is azodite test, aniline with benzene diazonium chloride. We are going to get a yellow colored dye. Remember, this is the acidic pH and 0 to 5 degrees C temperature. Very important to mention the temperature. Organic compounds containing nitrogen. So what are the differences? This is methylamine, dimethylamine. This is a primary amine. This is a secondary amine. Again, primary, secondary, tertiary amine. Any example they can ask you. This is methylamine versus aniline. That means we can use here, in this case, azodite test. Why? Because this is an aromatic amine and this is an aliphatic amine, although both are primary. Benzylamine and aniline is also similar. Benzylamine is CH2NH2. So this is also a normal primary amine and this is aromatic amine. So for both these, we can use the azodite test. Now, next we have conceptuals from each chapter. The conceptuals, I'm just giving you an idea. You can just go through the answers from the book, the NCERT topic wise. I've picked up the important questions. For alkyl what you need to focus on, if you know the mechanism of SN1, SN2 with suitable examples, you know how to distinguish them. I have a video on my channel where I have distinguished between SN1 and SN2. So just remember at least 4 important points to distinguish. You can use rate, order, steric hindrance, solvent effect, and intermediates or transition state. These points, or even optical activity, right? The optical alignment, whether there is Walden inversion or no Walden inversion, any 4 important points you must keep in mind because it is expected that they ask you as a 2 marks question or some indirect question in the form of a numerical, any form. But you should be very thorough with these concepts. And why do tertiary alkyl prefer SN1? You must explain in the on the basis of a stable carbocation, right? While primary prefer SN2. So the 2 important keywords. Children, remember, whenever you're attempting a subjective answer, you must highlight the keywords. Like while you're answering this particular question, why do tertiary alkyl prefer SN1? Whatever lines you're writing, just highlight tertiary carbocation is more stable. Highlight that. Just put a line under that. And here say there is least steric hindrance. So whatever long story you're writing, avoid writing unnecessary long stories in your answers. See that your answers are crisp, sharp, to the point, right? So that way you don't miss the main point. Underline, highlight the main terms. Elimination reactions, why does? Now, this is given in a box after SN1, SN2 in your NCERT. There's a box where elimination and SEDZEF, below the SEDZEF rule, there's a box where SN versus elimination comparison is discussed. Here we need a better nucleophile. Here we need a strong base. So this question comes from there. Why does elimination compete with nucleophilic substitutions, or explain SEDZEF rule with an example? For this, cram the definition and one example to quote with it, right? Then preparation of alkyl explain the preparation of alkyl from alcohols and their reactivity order with different halogenating agents, like with PX3, with SOCl2, etc. Right? This is from preparation topic. Then reactivity and stability. Discuss reactivity of alkyl and nucleophilic substitution reactions. Why alyl and benzyl halides are more reactive towards SN1 reactions? Again, based on the highlighting point is going to be based on carbocation stability. So why do vinyl and aryl halides not undergo nucleophilic substitution? The major point is partial double bond character, right? With a stress on resonance plus R. Draw the resonating structures, and then 3 more points. They are given very well in your NCERT. So mention each point in brief and just one line to describe that point. Resonating structures are a must if this is asked as a 3 marks question. Okay. Then what is Walden inversion? Explain with an example under stereochemistry. These points are important. Then chirality, enantiomers, resolution, racemic mixtures. Any of these definitions can be asked with examples. Explain the stereochemical outcome of SN2, Walden inversion, and just prepare your answer with at least one example. And these points are children going to prepare you even for multiple choice questions. Then Worth's reaction. I have already told you Worth's reaction. Write a note, an example, and why it is not preferred for synthesizing alkanes with odd number of carbon atoms. You should be prepared with this. So Worth's reaction, is only used for symmetrical and even number alkanes. So even something like isobutane cannot be prepared using Worth's reaction. Why? Although it is even numbered, but it is not symmetrical. So must remember symmetrical, even. Only these two types of alkanes can be prepared from alkyl halides using Worth's reaction. And then we have electrophilic aromatic substitution. I told you this topic is important in every chapter basically, but effect of Cl on benzene ring towards ES. This is in text question 10.9. Prepare it well. It's well explained in NCERT. Prepare this well. This is one of the important subjective questions that can be asked. Then environmental effects of alkyl halides. Explain the effect of chlorofluorocarbons on ozone layer. This is from the last 2-3 pages. Why are haloalkanes considered greenhouse gases? Which ones are, give examples. They can ask you in multiple choice questions. Name some greenhouse gases or some alkyl halides which are used for this purpose. Then comment on the precautions to be taken while storing chloroform. So your answer based on this reaction is important. And then name and structure of DDT and its limitation or usage or why this use has been stopped. Those points from the last page. And also, I'll be putting a link of the alkyl halide videos that are already there. Children, there's one 90 question test that I uploaded. I don't remember last year or last year, just before the boards. And uh, children's version, all the questions that were asked from that chapter were from those 90 questions. These are exhaustive 90 questions video. You can practice this like a test after you prepare this chapter. I'll be putting the links below. Then we have alcohols, phenols, ethers, preparation of alcohols, phenols and ethers. How will you prepare alcohols from? The preparation from Grignard reagent, any alcohol. Let us say I ask you, how are you going to prepare ethanol from any Grignard reagent? So you need to be able to relate that. Fine. From carbonyl compounds, from aldehydes ketones, reduction of aldehydes ketones leading to alcohols, do it well. Mechanism of acid catalyzed hydration. This is one important question which is generally asked. And remember this well, acid catalyzed hydration. So just remember it well. The common mistake that children do is when alkene has to be initially shown as protonated form, treated with hydronium ion, make a carbocation, and then make attack of water feasible. So just learn it well from NCERT. Don't do it superficially. Okay? There are marks for steps. Explain the industrial preparation of phenol from cumene. This has always been an important question. Write a method for preparation of ether by Williamson synthesis and explain its mechanism. So Williamson synthesis and its mechanism, plus also its limitations. Limitations are also important. Okay. And this year, what my prediction is, normally all the questions that I'm explaining, they've been directly asked in the previous years. But this year, I'm expecting the same concepts will be asked, but they'll be a little more in a twisted, like if you look at the sample paper, earlier question used to be asked, compare the boiling points of various alkyl halides. This time in the sample paper, they've given a graph, right? They've made a graph like this and they've asked you to read like and then answer what is the order of boiling point of various alkyl halides. So they just expected to make the questions a little indirect, but if you know the subject well and if you've done things with understanding and you've not only crammed the previous year questions, you'll be able to perform well. Physical and chemical properties. Why do alcohols have higher boiling points than ethers and alkanes? Right? Hydrogen bonding is the reason. So prepare this answer well. Compare boiling point of primary, secondary, tertiary alcohols. Explain the solubility trend of alcohols and phenols in water. And why does phenol show more acidity than alcohol? This is a always ever important question. Phenol and alcohols. Compare the acidic nature basically of phenols, alcohols, and carboxylic acids. Prepare this answer also well. Clear? With resonating structures. So explain Lucas test and differentiate between primary, secondary, and tertiary alcohols based on their reactivity with concentrated HCl and zinc chloride. We've already talked about this. Explain the oxidation of primary, secondary, and tertiary alcohols with suitable reactions. Various oxidizing agents, and also you should know the oxidation can be done either by putting O or by removing H. Fine. So you've done two methods. One is dehydrogenation, and dehydrogenation was like if you remove hydrogen. The advantage of this is further oxidation is prevented. Clear? And another one is by adding O. So both these methods should be done properly. And compare acidity of alcohols, phenols, carboxylic acids with proper reasoning and with proper resonating structures. Why is phenol more reactive towards electrophilic substitution? This is an activating group. Why? Because it's plus R dominates over minus I. So this is the highlighting point of your answer. Explain bromination of phenol in different conditions. In different conditions means bromine water, bromine CCl4, monobromination and tribromination. So with clarity do that, and mechanism of nitration of phenol, and also explain the orientation. Why? Again, based on plus R dominating over minus I, presence of OH is ortho-para directing. So whether ortho will dominate or para will dominate, also taking into consideration the chelation due to intramolecular H bonding. So keep all those points and prepare that topic well. Ethers, why do ethers have a low boiling point compared to alcohols? Again, we have hydrogen bonding here and there's no hydrogen bonding here. Now, also, children, remember the solubility comparison. This is the boiling point comparison. Just remember the solubility comparison. Explain the acidic cleavage of ethers with HI and why phenolic ethers react differently. And under this topic, this is the only important topic under ethers mainly. Under this topic, also prepare these three. So the acidic cleavage of diethyl ether, of anisole, tertiary butyl ether, and with limited amount of HI and also with excess HI. These are the points that you should be clearing. This is very clearly given even in in-text question in NCERT. So just prepare these points. Why do ethers not react with sodium metal, but alcohols do? Again, because alcohols have an acidic H, ethers do not have. Okay, so prepare this. Then we have aldehydes, ketones, and carboxylic acids. The first important reaction is nucleophilic addition towards HCN, sodium bisulfite, methanol. This is acetyl and hemiacetyl formation, hydrazine or other ammonia derivatives, which is given in the form of table. You should just know the reagent and the product form. Okay, why do aldehydes react faster than ketones in nucleophilic addition? This has to be given under three headings. You must show steric effects, inductive effect, and then compare. Okay. And here I really want to bring to your notice one point. Just remember a very important point. Supposing I ask you to compare the reactivity order of formaldehyde, acetaldehyde, then acetone, and then benzaldehyde, and then benzophenone, or maybe acetophenone, right? I ask you to compare the reactivity order. You would say this is more reactive than this. Then the reactivity order will be this, followed by this. And then children generally make a mistake at this point. Okay. So next should be benzaldehyde, and then acetone, and then acetophenone. So just remember that all the aldehydes will be coming first, followed by all ketones. So the order goes as aliphatic aldehydes, then aromatic aldehyde, then aliphatic ketones, and then aromatic ketones. And as the group keeps on becoming bulky, the reactivity keeps on becoming less. So learn it as a subjective attempt with reasons or in the form of this example. Oxidation and reduction reactions, write a chemical test to distinguish between aldehydes and ketones. This we've already discussed, and we have covered all this in the form of name reactions also. So it's important either ways. Then special reactions of aldehydes and ketones, very important. Canizero, aldols, aldol reaction, And why does formaldehyde not give aldol condensation? Because of absence of alpha H. So these are ever important questions. Then we come to carboxylic acid. Carboxylic acid, most of the reactions are asked in the form of conversions, like convert ethane nitrile. Ethane nitrile. You must also focus on the names. Ethane nitrile. Partial hydrolysis with 1 mole of water is going to give ethanamide, and complete hydrolysis is going to give this. Or in other words, I can also say concentrated acid means less of water is going to give partial hydrolysis, and dilute acid that has more of water is going to give us carboxylic acid. Similarly, cumene to benzoic acid, methyl magnesium bromide to ethanoic acid. This is treatment with carbon dioxide. Okay, cyclohexene to adipic acid. Cyclohexene means this. So just treated with hot alkaline KMNO4, strong oxidizing agent, we get adipic acid. Adipic acid is hexane 1,6-dioic acid. Yeah. Then benzyl alcohol to phenyl ethanoic acid. Benzyl alcohol. This is a simple conversion, NCERT conversion to phenyl acetic acid. Right? So one thing that you have to remember is we can never convert OH to something like this. This is one blunder you children make, so please be extra careful. We'll have to convert this first to benzyl chloride. By treating it with what? We can treat it with anything, PCl5, HCl, zinc chloride, anything to convert it to this, and then treat it with KCN to get to this compound. And once this is formed, then complete hydrolysis is going to give us this. Right? This is one common mistake. And another common mistake that children tend to make is if you want to convert ethyl chloride to ethene, you have to use alcoholic KOH. Halides to alkene is alcoholic KOH, but if you want to convert alcohols to alkene, it has to be concentrated sulfuric acid. Remember, to dehydrate, to remove water, concentrated sulfuric acid is required. This is one common mistake children make, so please keep this in mind. Carboxylic acids, now again, why do carboxylic acids have higher boiling point than other functional groups, than aldehydes, ketones, even than alcohols? So when it comes to aldehydes, ketones, it's simple. Carboxylic acids show H bonding, aldehydes, ketones do not. But if I ask you to compare between alcohols and carboxylic acid, then you can so say this shows more stronger H bond. Why? Because of an electron withdrawing group, carbonyl. So this also has H bond. Both have H bond, but this has a stronger H bond due to withdrawing CO. Then mechanism of esterification, as given in your NCERT, you must know. Acidic nature, we've already compared. Explain the reaction of carboxylic acids. These are just reactions you have to remember. And then the last one I would really want to bring to your notice, phthalic acid with ammonia, or basically any carboxylic acid with ammonia. Children, just remember carboxylic acid, if I ask you to treat with ammonia and I leave a dash, this is one common mistake that children make. Remember, the first dash without heating is ammonium carboxylate. And after you heat it, it's going to lose water to give amide. And if you really strongly heat it, it can further lose water and convert to nitrile. And if I'm talking about phthalic acid, this phthalic acid, when I'm going to treat it with ammonia, it's going to first form ammonium phthalate. When heated with ammonia, it's going to form phthalamide, CONH2, phthalamide, phthalamide. These are points that are going to be important even for your JEE and NEET, etc. And if I strongly heat, it is going to further lose, H, right? This was phthalamide. It is going to lose ammonia. It will lose ammonia and convert to phthalimide. C double bond O N H and this compound. This is phthalimide. I hope this is clear now. Right, children? This is very important. Yeah. So nitrogen containing compounds, amines and diazonium salts, the important questions, the regular ones. How amines are prepared by reduction of nitro compounds. Gabriel thalamide, this is very important. This can be asked as a name reaction or as a conceptual. And why is it suitable only for primary amines? Then Hoffman degradation, this can be asked for conversions. And why it produces a primary amine with one carbon less, or you can be asked to convert using a particular example. Okay, they can ask you anyway. These are important ones that you must remember. Basicity of amines, compare basicity of aliphatic amines, aromatic amines, ammonia in gaseous as well as aqueous phases with proper examples. And you must know that in case I'm talking about a gas phase, then it's simple tertiary, secondary, primary, and we generally use the inductive effect. More inductive, more basic nature. Okay, but when it comes to aqueous, you know methylamines and other alkylamines. There's a different order. So just remember this carefully. Do it from the book carefully. Aniline less basic than ethylamine. While attempting this answer, you must show the resonating structures of aniline. And this is similar why aromatic amines are less basic than aliphatic. Both these questions are same. Then explain reactions of amines. Hinsberg test we've already discussed. Carbylamine we've already discussed. Reaction of aniline with acetyl chloride. This is aniline with acetyl chloride. This is going to give us NHCO CH3, right? And benzoyl chloride, short and warm in reaction. So do these well. Electrophilic substitution in amine, again the same thing. Why aniline is more reactive than benzene? Why? Because it is again plus R dominating over minus I, so it is an activating group. Explain bromination of aniline and why tribromination occurs. Again, you have to show that this is activating and explain that, and then you must say that if you want monobromination, then you will first acetylate it and then proceed. Okay, why does nitration of aniline acidic medium gives a meta-nitroaniline? Your focus should be on explaining that in acidic medium, aniline is going to convert to anilinium ion, which is a meta-directing group. Clear? Whereas aniline was an orthopara-directing group. So these points you have to keep in mind. Reactions of diazonium salts. How is benzene diazonium chloride prepared? Give reaction. They can ask you to write a note on diazotization, or they can ask you some specific points about conditions and limitations of this reaction. Then Sandmeier's reaction and coupling reaction of diazonium. Diazonium is a very simple topic, so just remember the reagents and the products. Then compare boiling points of primary, secondary, tertiary means. Tertiary means why do they not form stable diazonium salts, and why is aniline insoluble in water but soluble in diazonium in dilute acid. Okay, this is because of bulky nonpolar benzene ring, and this is why because it reacts to form anilinium chloride. Anilinium chloride. Aniline is a base and reacts with dilute acids, so it is soluble. So I hope this really helps you, children, to prepare. This is more of a checklist for you. I hope it really works for you. So do like, share, subscribe, and do leave a comment if you need any other help for your like physical or inorganic or in any way. Please feel free to share. Thank you. God bless you all. May your exam rock and may you rock always. God bless you.